was introducing myself. So you know who I am. You know that I'm not very good with angles. So when we were advertising Vue storefront, we were talking a lot about its speed. So you can imagine how I felt when one day I came across our GitHub and found an issue written by a guy from Google, Alex Russell, pointing out that, well, our bundle is pretty huge, so it was like a slap in the face for me. But I'm the kind of person that reacts quite positively to feedback like this, so I was like, okay, so challenge accepted. And today I want to share with you what I learned during the process of Vue storefront optimization. So first of all, how many of you think that web performance is really, really important? Like, raise your hands. Okay, like a little bit more than a half, maybe half of the one that didn't raise their hands are shy people. So I will pretend that I'm smart. I will show some numbers, because numbers can't lie. So first of all, like, this really shocked me. 1 second is enough for the user to do a mental context switch. So in 1 second of loading, they can potentially leave our website and, for example, decide to see like funny goat video. Like, it's real. It's a real video. Let's see some other numbers. So 2 second load time reduction resulted in 50% more downloads for Firefox. For Firefox, it's pretty huge, only 2 seconds. 1 second slowdown for Aberdeen group resulted in 11% less page views. So it's also like 1 second slowdown. It's not that much. 2 seconds of delay resulted in 4% loss in revenue per visitor and 4% reduction in clicks for Bing. I'm not sure how many people use Bing these days, so this can be either big or small. And this one is quite interesting because cutting page load time half resulted directly in increasing sales for auto anything. So given all these numbers, we can like make a simple equation that speed equals money. Can we agree on this? Okay. So now that I hope you're all convinced that it's really important to have a performant web application, let's see what influences this performance. So first of all, when we have application, we need to request some assets from the server. So the bigger this asset is, usually the longer we need to wait for this. So once we have them in our browser, we need to parse them. So JavaScript engine is parsing it, making nice AST tree. And the bigger it is, the longer it takes. Once we have it parsed, it's time to execute this code. And guess what? The bigger the file is, the longer it takes to execute. So it looks like the main factor influencing the performance. Of course, there are a lot of factors, that the main one right now is the bundle size. So let's create a simple application and see what problem in terms of this bundle size we'll encounter and how to solve them. Disclaimer, examples are in Vue.js. How many of you know Vue.js? Okay, so for the rest, I will make a very, very simple introduction. So in Vue.js, we have something called single file components. These are basically files that are ending in .vue. And you're putting everything related to the component in here. So here's HTML markup, styling, JavaScript, etc. And that's all. So this is all you need to know. Now that we are all Vue.js experts, let's come back and create the application. So it usually starts quite innocent. Like, we have our entry point, we have a library imported, we have our root component, but after some times it gets a little bit more nasty. We are adding a router, we are adding some roots, and every new module or library that we will add to our application means bigger bundle. Bigger bundle means longer download. Longer download means longer parsing, longer execution, and we remember speed equals money, so the obvious thing is more features, less money. Yes? So as you probably guessed, it's not like this. But to understand how to solve the issues with growing bundle, we need to understand how this bundle is constructed. So how Webpack bundling works. So it appears that under the hood, Webpack is creating something called a dependency graph. So it's traveling recursively through all our dependencies from the entry point and adding them to the graph and constructing something like this, which is not something that we can reason from, but to better understand this process, let's have an example. So let's say main.js is the entry point of our application. So Webpack is going to this main.js file, scanning it, seeing all its dependencies, adding them to the graph. Now we don't have direct dependencies in Vue, Router, and the app view. So we are going to router.js, scanning it, added its dependencies to the graph, later about Vue. So now we have everything bundled, and we have our app.js bundle. But there is one problem with this. Depending on the state of our application, you might not need some parts. You can imagine that with such simple application, it's okay, we can live with this. But as our application will grow, we will be downloading more and more redundant code to the user. So we need a way to split our code and ship only the needed parts. This is why Webpack have a feature called code splitting. This name is very descriptive because it allows you to split your code into different bundles. And the technology complementary to this is lazy loading, which helps you load the splitted chunks on demand. And the syntax for this is really, really simple. So instead of importing something directly, like in the top, when we import a module directly, it ends up in the current bundle where we are. But when you wrap it in a function called dynamic import, then it will be entry point for another bundle. So in Vue, it's pretty simple. We can use the same syntax. In React, things are a little bit complicated, but still rather easy. In Angular, as you can expect, it's a little bit harder. And the funny thing is, for now, in Angular, you can only lazy load full modules. So you can't lazy load individual components. It's going to change in Angular Ivy. But right now, the thing you need to do is to pass the exact location of the lazy loaded module into load children property of your route. So with Angular Ivy compiler, it's going to change, and it will be finally possible to lazy load individual components. So going back to our Vue.js example, this is route declaration for Vue-router. We only have a path and component, so both of them are dynamic imports. And with this configuration, our Webpack build will throw 3 files. The app.js is a main bundle, and we have 1 bundle per route. So now we are pretty sure that if user is entering any route, he or she is downloading only the needed code. If any of you is using Nuxt.js, who is using Nuxt.js? Okay, so if you slept, it's not a problem, you have this out of the box. So rule number 1, split your code per route. And this rule will give you like the biggest impact on the performance. But of course, we can do like much more small improvements. So what else we don't need on initial download? We already told that we don't need other routes. But we also don't need components that are not visible immediately, like pop-ups, some sidebars. So basically off-screen components. So rule number 2 is load off-screen components lazily. In Vue, it's also pretty simple because you only need to use VIF directive. So this directive is basically telling us if you should render something or not. It's pretty important to know that VIF set to false is not adding something to the DOM at all. So if this is set to false, we're not invoking this function in components. Therefore, we're not downloading the model, but Vue is reactive. So when we change this property to true, this property, this function will be invoked, and the component will be downloaded. What else? What else we don't need on initial download? Any guesses? Okay. So I will spoil. So there are some libraries. In most cases, these are like 90% of libraries that we also don't need on initial download. Usually, these are the libraries that are doing something as a response to the action. So it can be, for example, a Lodash. It's very, very complicated function that is, well, concatenating to arrays. So we can imagine that it can be a response of some user's action, and we don't need the whole Lodash loaded right up front by the user, because he might not even click this button. So it's good to load such libraries lazily. Okay. Rule number 4. There is a very common pattern in front-end world that I'm not a fan of, and it's actually an anti-pattern of bundling all of the node modules into one bundle called vendor bundle. Vendor bundles are not anti-pattern, but bundling all of your node modules into one file is. Why? So usually, if we will bundle everything into one file like this, we will end up with the same situation like in the previous slide. So we might not need some of them. You can imagine that this can escalate pretty quickly, and we can have a lot of libraries that we don't need. So it's much better to leave the basic per route code splitting and let these libraries be distributed. Okay, but you can ask, what about code duplication? What if we will have something like this? What if we will have Lodash in one route? Then, when we will download the second route, we'll download Lodash again. So this is not what we want. And to fix this, we just need to add this property to our Webpack config. It will basically tell Webpack that it should optimize all chunks that it has in node modules and in our application, and find the common chunks, so the ones that are used in many different bundles, and make them a separate bundle. So right now, Lodash will be a totally separate bundle that will be downloaded only once. When we are in the world of the libraries, there are tons of them to choose. So you can imagine, for example, slider. I'm pretty sure that each of you has your favorite slider that you use mostly, but depending on the situation, we might need some other libraries. So there is a very nice site called Bundlephobia, which enables you to find equivalents of the libraries you're currently using, to find the smaller equivalents. Also, it gives you a very meaningful information what will be the impact of the library that you plan to import into your application on the performance. So here I have a Vue carousel, which is a pretty small library, and you can see that on the 2G, on the 3G, it has pretty huge impact as a slider. But what is even better with the Bundlephobia, it can suggest you the alternatives. So you can check other use cases, and you can immediately check which is bigger, which is smaller. So if you care mostly about performance, you can just choose a smaller equivalent and check if it's fitting your use cases. If the current slider doesn't cover everything you want, you can just find some another. Okay. So now that we have our bundle size under control, there are some techniques that can help us optimize the response from the network. First of all, the thing that we can do is not making a response at all, so making use of the cached assets. To do this, we can use technology called service workers. How many of you know what service workers are? Whoa! This is nice. Usually it's like 10 people or something like this. So actually, service worker is a proxy between your client application and your backend application. So it works more or less like this. When you are sending a request to the network, service worker can do something with it. By saying something, we can, for example, check if we already have this request in a cache, and if it is, serve it immediately. And you can imagine that usually we have like something called app cache, which are the static assets, HTML, CSS, JS. So these are the things that are not changing in our application that much, also if they are hashed. The thing that is dynamic is the data from the server, so usually JSONs. So we can cache this app shell and make it load almost immediately for the user. So this is really nice. And the good thing about service worker cache is that it persists even if the browser is closed. So once someone is entering your website, every next visit will be almost instant. And if you're using Vue-cli PWA plugin, then it adds your functionality, adds this functionality to your application. Installation is like, you just need to add this and it works. If for the people that are using Nuxt, there's also a Nuxt PWA module. The installation is 2 times harder, so you need to install it and enable. And no matter which one we will choose, we can also choose some other options that are not related to the Vue.js. For example, Workbox is a great tool for this. Workbox is a tool from Google that allows to place nicely with cache and basically build progressive web apps. So no matter what we'll choose, under Application tab and Cache Storage, we'll see which exact requests were cached and served from cache. OK, so what else we can do? We have our bundle size under control. We are making heavy use of already cached assets. But what with the things that we haven't downloaded yet? So there is a technique called prefetching, which is like, in short words, downloading things upfront, things that we will probably need in the future. And here comes rule number 6, prefetch lazy loaded resources. So we are making heavy use of this code splitting, and therefore our UX can suffer, because each time user performs some action, there are probably some bundles that they will need to download. So why not to download them upfront, right after application is set it up? So to do this, the syntax is extremely simple. We just need to add this. It's called Webpack magic command. And any import that we have, if we will add this magic command in there, it will be prefetch. So the prefetch is happening when the browser is on idle mode. So once everything from the initial bundle is executed, then we are prefetching the lazy loaded resources. And actually, this magic command will just add this to head of our application. The script will add it. Of course, like, it might not be the best idea if you have tons of these dynamic imports to do this everywhere, because then we don't have that much control over it. So you can also use some plugins for this, for Webpack, and use, for example, regular expressions to catch the files that we want to prefetch. Vue-cli 3 is prefetching lazy load chunks out of the box, so you don't need to do anything like this. Of course, you can't forget about like the standard things that mostly Webpack is doing under the hood, and you probably have no idea that it is doing, like some compression, minification, etc. Also, the DevOps are doing a lot of stuff to optimize that. Even I have no idea what it is. So these are like the standard things that you can do to optimize the bundle size. But it's also good to measure it, because if we can't measure, we can't tell if there was any improvement. Like, we can tell, oh, yeah, I think it loads faster. The bundle is smaller, but what are the best tools to measure? So first, before we will do any optimization, it's good to check what we should optimize. So there is a DevTools coverage tool that you can run on any website and see actually which part of the code was executed. So if you have MacBooks, you need to type Command-Shift-P. If you have Windows computers, it's Control-Shift-P. It's pretty nice. It's like a finder for developer tools. So when we type coverage and run it on a website, we can see which parts were executed. The red part is actually the part that wasn't executed at all. And this is a Vue.js.org, so they have a lot of work to do. So once we know that there is a room for improvement, it's time to identify the parts of our application that can be improved. So this is like a must-have in terms of optimization. Webpack Bundle Analyzer. It will show you visually which packages are landing into your bundles, and will show you visually how much size they're taking. So by only seeing this, we see how much our components are taking, how much our node modules are taking. Also, we can see that Lodash is pretty huge, and maybe we should change it. So installation is pretty easy. We just need to require the plugin and add it as a Webpack plugin. Then, when we will build our production code, we will see it on some different host. Also, it's pretty good like to keep on track of the size. And there's a bundlesize package where we can determine our performance budget. So let's say we don't want to exceed 300 kilobytes. So in our package.json, we just need to specify the maximum size of our package. And after each build, if it will exceed this size, the bundlesize plugin will throw an error. Also, if you're using GitHub, it has a very, very nice GitHub integration. Also, there is one nice plugin for VS Code. It's called import cost plugin. And it's basically showing you the size of the things you're importing. So it works more or less like this. It's pretty nice that it's showing you like the real numbers, so the exhibits one. And the sad truth is, no matter how much you optimize, users will still need to wait. And making this waiting experience proper is also a part of the optimization process. So we want them to like wait like a boss, see what's happening. And we can use loaders for this. They are pretty nice if something is loading below 1 second. The more user needs to wait, the more information we need to provide. So then we can think, for example, about placeholders. You probably know them from Facebook, from Slack. This is a good example. So where we should use placeholders and loaders, first idea, component is loading, dynamic component is loading. The second one, data is loading, because we don't want to display like empty components to the user. We want to display them some data, so we can show some loaders until the data is loaded. So if we have dynamic components and we want to show some loaders before they are actually fetched, in Vue.js we have Vue async component for this. We're basically providing a component that will be shown when it's loaded, a timeout, a proper delay and also an error component. It's usually like the error component usually is useful when user is offline. In React, we have a suspense package for this. So we are combining React Lazy with React Suspense, and we are providing a fallback for this. The fallback is actually something that will be there until the component will be fetched. Also, there is a very, very nice article. So if you care about waiting experience, it's a good moment to make a photo. It's a really long one, but it will give you like in-depth knowledge how to deal with this. And this is everything from me. Thank you very much. Any questions? I see a hand there.
Thank you. Of course, JS is a major feature that spans our speed and reduces page load time. But what about images? Because they're often too large. For example, I wanted to ask about a particular example. On the medium.com, you often see that images are loaded not instantly, but first, image loads in small resolution with a huge blur effect, and then as images loads, it will then load a large one and with full resolution. Also, often we are depending on Google tools for measuring performance. For example, Lighthouse, yes. How does this kind of image optimization impact Lighthouse?
So
yes.
The talk was mainly about the JavaScript performance because like the whole performance is a pretty huge topic. So images, of course, are influencing very much your loading performance, especially if you don't have HTTP2. So you should definitely load your images lazily whenever it's possible, especially the ones that are above default. For example, in Vue.js, there is a nice library called vlazy for this. I'm pretty sure that there are such libraries for React, for Angular, etc. There are like different techniques, so you can either use a placeholder for this, or you can use a low resolution image. Also, it's pretty important to have responsive images. So different image for mobile, different image for desktop. Yeah, so this is about the images. Any other questions?
More questions?
Okay.
Seems like no, so we thank our speaker. That's all. We can go to the break.
Okay, thank you.